Hello, this is part 2 of your series on intro to what we are actually doing in this class. Off we go. Watch part 1 first. Off we go. Gold! Alchemists of the past were really interested in turning other things into gold. They wanted money, they wanted fame, they wanted shiny things. Yeah. There you go. Okay. And that wasn't all. I think it sometimes is reduced to that, but that's not the only thing folks were looking for. They were looking for like what is the essence of a thing? What is a thing? How can we find the substance that everything else is made of? Is there a substance everything else is made of? This was debated for forever, like since people could like think about questions like that. We've been trying to wonder like what is it inside of things that make them what they are. And so with that, we start this class with a question and a challenge. And like I said, we go across the hall into lab and we try to do it. So our initial challenge is, can we make gold? And specifically, I was going to write challenge. Let's do this here. There's our challenge that we always start with. Can we make gold? And specifically, we take something that already has some money value and we mess with it. Can we turn a penny into that elusive into gold? Can we do it? Is it possible? We do a little bit of thinking about this question, then we go across the lab, we do some stuff. I will link you a video, but I'll describe it also. And so we take a penny out of your pocket, or you know, wherever you keep your pennies, and you get to take it home afterwards, and we mess with it. So we do the following things. How do we start? We heat it, we mix it with some stuff, we mix it with some other stuff, do a bunch of heating and mixing and cooling, and it changes. So we mix it with, let's just say I mix and heat and mix and heat and cool and heat and mix, and it changes into, it appears, we do step 1 and it appears, you may have done this in a different class, I'll link you the video and stuff like that. First it appears silver. We're like, cool, okay. Now we have like a really hot silver penny. But we're not quite there yet. We want more. We do some more stuff to it. We're gonna mix it with another thing and heat it again and cool it there, cool it off, and then it starts to shine through, changes again. And that's when we finally get our gold pennies. And you can take them home and they look gold. And every year some people choose to go with silver. They prefer a silver penny. Some people prefer gold pennies. And on our first lab day, we actually leave it there. And soon, or at some point, we come back and we ask the question, what happened? How did we do that? What, clearly this occurred. Something happened. We made a change. It started off looking like that gunky old penny in your pocket, may or may not think that much about that penny, but we can do some stuff to it and it totally changes its appearance. It looks totally different. So yeah, what do we do? What did, and then we ask ourselves, did we actually make gold? And sometimes you think about it a little bit and you come to the conclusion that we probably did not. Probably no. And you think about it and you're like, among other things, we did this in a single class in a chem lab. If we were making gold, we would not be like sitting around doing basically anything else. We would all be in the chem lab mixing things, heating and cooling our metals, and making, if we're really doing it, it's all we would do, and then gold would lose all of its value, right? But right, that's what we would be doing with ourselves. But something did happen though, right? Like some change occurred. And this is when we get into the question of what makes something what it is. What makes something what it is? How do we know that we didn't just make gold? How does anyone know if they did or didn't actually make gold? What is it that determines what something is, its identity? It's like, is it gold? Is it not gold? How do we know? And what is that identity piece? And we start to throw out some words that you've maybe heard, chemistry words. I'll ask you, like, what small particle builds stuff up? What's the little thing inside? And we start thinking about insides. And the little word that you've probably heard from some year before, everything is made up of atoms. Inside atoms. So atoms are, atom originally comes from a Greek word atomos, which means indivisible. By this point, we realize that atoms are divisible, but once we divide them, they lose their properties. So smallest piece of something that retains its properties. Okay. But we're gonna get even deeper and more insidey than that. We're gonna go inside the atom. And I'll ask you, this is all about connecting things you already know to things that are new. Inside an atom, we've got some particles. I'm debating if I want to put this here. Inside atoms. Let's put it here. Particles. Particles inside, now it's starting to actually sound like chemistry. Okay, so particles inside atoms. You may have heard of these. One starts with a protons. You may have heard of the whizzy things on the outside. And that other one that just kind of hangs around so far. And it's a bummer of the virtual recording world that I just give you these words, because if we were together, you would bounce your ideas off of each other and think of lots of different words. There are words that you are thinking of that I am not writing down because I can't reach your mind, unfortunately. If we were together, you could call them out and we could like figure out how they all like integrate and like into each other. But for here, we're gonna take the next page of your notebook. Ready? So here's your first page of stuff. Give yourself a second page of stuff. We're gonna draw a giant chart. Okay, off we go. So we're gonna draw a chart, and we're gonna say inside atoms. Alright, because we're still on this question of like, we haven't quite solved it yet. What makes something itself? So we know that the atom is the smallest component of a thing, an element, really anything, that retains its own properties. And we know that inside atoms we have these things. We're going to make a chart on the side. So these are called particles. We've got protons. And electrons. And neutrons. Okay. Alright. Okay, so things that you might know about these things. You might know where in an atom they live. So where are they in an atom? They're all inside, but where inside? So where are they? You may have heard of or know. Oh, this next word. Their charge. And charge has to do with. Charge is kind of like electrical. Think of. How do I describe charge? Charge is really a part of the identity of the particle, and it has to do with anything. I mean, among other things, charge. Oh, think of charging your cell phone. There we go. That's what I'm actually trying to say. Someday we'll do a way deeper dive. I'm not going to do that right now. Think of charging your cell phone, because that charge on your cell phone is actually completely related to these particles moving around, shifting positions. You charge your cell phone, and then it has that buildup of charge to then create electricity and like cause your cell phone to be able to turn on and stuff like that. It is a movement of charge that does that. That'll be our intro for now. The charges that we primarily look at are opposites of each other. And when you charge your cell phone, you move the orientation. I'm not going to go real deep right now, but think of charging a cell phone. Okay. And here, okay, so we've got where are they, the charge that they have. What do they do for an atom? Why do we care? So like kind of like charging your cell phone. What do they do and why do we care? What do each of these particles do? Which again is a huge question. And I'm just going to make sure I'm getting all of the questions. How many? Oh, yeah. Great. Love it. Okay. These next three go together. How many are there in an atom? How many are there in an atom? If we change how many, sorry, this is a little clunky. Can we add and remove? Oh yeah, can we add and remove? And if we can, what do we get? And then this is the end of your table. This is a little bit of a big table. Can we add and remove? What do we get? Okay. What do we get if we add or remove this particle? Whew. Alright. I'm going to do some of this a little bit faster because I get that this video is getting long. Yeah. And again, if you have ideas, first things first, if you need to, pause the video and come back to it. But let's keep on keeping on. I will take this a little bit faster. These two are the two that you're most likely to remember from previous years. You may remember that the charge of a proton is positive. They both start with P. So a proton has a positive charge. A neutron has a neutral charge. However, this next word also begins with an N. Electrons have a negative charge. Okay. You may remember that some of these things live in the center of the atom. That kind of sounds like one of these words. And some of these things live on the outside shell. So we've got protons and neutrons on the inside in the nucleus. Alright, so protons and neutrons are in the very center of the atom in the nucleus. And it's the electrons, the negative electrons, that are zipping around on the outside in the electron cloud. Okay, and that's something that's going to help us out here when we get to what they do. The things on the outside, these electrons, are the things that will bond with other atoms. So the outside component, the electrons, are what will do bonds, chemical bonds, with other elements. Okay, so electrons are on the outside in the electron cloud, and since they're on the outside, they are able to go and bond with other atoms. Protons and neutrons are both on the inside, and we'll do the rest of this too, but here is our moment where our original question is what makes something what it is. And we said what makes something what it is something inside the atoms. It's the identity component on the very insidemost part of the atom. Like inside of the atom is the thing that makes an atom what it is. It's those positive particles deep in the inside that give the atom its identity. Here is our key to our original question. All that positive stuff on the super inside of the atom, this is the identity of the atom. So when we go to figure out, did we actually change our penny into gold, what we're looking at, what we're looking for, we want to know the identity. Who is this atom that we've got? We are going to look into the farthest innermost regions, the inside of the atom. We're looking for that positive charge in the nucleus inside. Those protons tell us the identity of the atom. We can even write that. So protons tell us the identity of the atom. Oh, that's sideways. Yeah, protons tell us the identity of the atom. Okay. So we're still on this question, can we change the identity of the atom? Well, let's see here. It's on the inside, it's in the nucleus. Can we change it? Can we add and remove protons? And what do we get if we add and remove them? How does that even work? So how many is the atomic number? The number of protons is the atomic number. If you're like, okay, I just wrote that down, but I don't know what atomic number is, we can bookmark that. I'll do it in a separate video, but I'll do it either today or tomorrow. Atomic number. It's on the periodic table, but I'll do that. I'll go deep on that very soon. Let's get that for here. Can we add or remove it? Let's do it. Okay, proton. Okay, atomic number is going to come up again here. Atomic number is also number of neutrons. No, that's not true. What am I talking about? When we're looking at atoms, sorry, if I could edit videos, I'd delete that. In an atom, that atomic number is also the number of electrons. Okay. It's getting a little small. And you're noticing that the atomic number is important. Great. Bookmark that. We are coming back to it. The atomic number is always the number of protons. In an atom, that atomic number is the number of electrons. And the number of neutrons, don't worry too much about this, but I do want to give you this information, is the mass minus the protons equals the neutrons. Okay. Mass minus the protons equals the neutrons. That's kind of small. And we never did the identity of the neutrons. What do they do? Neutrons are the glue that hold the nucleus together. That holds it all together. Nucleus is made up of a whole bunch of positive things. In science, opposites attract, same thing, repel, whatever, go with it. So your nucleus is full of all this positive stuff. And it's so much positive that it should kind of blow itself all apart. Your neutral neutrons, their job in the world is to hold the nucleus together. So with all that positive stuff in one really, really, really concentrated spot, you would predict it would all fly apart, but the neutrons are the glue that hold it together. What do they do? Neutrons are glue. Can we change the identity of an element? Can we add and remove? If we do, if we add and remove protons, that's in the nucleus. That is nuclear chemistry. Same thing with the neutrons, also in the nucleus. If we add and remove neutrons, that is also nuclear chemistry. Okay, electrons are on the outside in that cloud. And actually, yes, we can add and remove electrons. Yes, we can add and remove them, and it's actually pretty easy. Sometimes it takes some electricity, but it's not really that hard to move your electrons. What we get when we add and remove electrons, you may have heard this word before also, we get ions. If we add and remove neutrons, we get isotopes. Ions is going to be week 6 of this class. Isotopes you covered in 9th grade, and we're actually not really going to go back to these. Here's the answer to all of our questions. Our protons are the positive stuff on the inside. They're the identity of the atom. If we add and remove them, we're doing nuclear chemistry. Here is where we get a new element. We're trying to figure out, can we change something into something else? If we add and remove protons, that is when we're actually coming up with a new element. Is this easy to do? No, it is not. It is nuclear chemistry. There's a real good chance that you will never interact with nuclear chemistry ever in your actual day-to-day life, because it's pretty dangerous, frankly, powerful. One way that you will interact with nuclear chemistry every single day is the sun. The sun in the center of our solar system is doing nuclear chemistry. So nuclear chemistry is kind of on that level. There are ways to do it that are less intense than literally the sun. But for the most part, we're not going to go there. And we definitely will not in our lab. Yeah, right? Okay, so it's relatively easy to mess with the electrons. That we can do, no problem. Messing with protons, pretty tough to do. You get new elements if you actually mess with that positive stuff in the center. You come up with a completely different element. Yeah, that is not a thing that we'll do in high school or college, frankly. Yeah, so, yeah, yay, we answered our initial question. Finally, what makes something what it is? We figured out it's the protons in the center of the atom that gives an element its identity. That's what it is. That defines who the element is. We figured out that you can change an atom into something else. However, you have to go mess with the nucleus on the inside. You have to change the number of those protons, do some nuclear chemistry. That's how you're going to get a new element. And along the way, the rest of this is most of where we're going, since we're not going to be doing nuclear chemistry in this class. What we will be doing is a whole bunch of this stuff. There we go. So what we will be doing is messing with the outside part of the atom, where all the electrons are, these negative electrons on the outside of the atom. These are relatively easy to mess with because they're on the outside. So we can easily add and remove electrons, and they're the core of what forms our chemical bonds. So everything that we do here that has to do with chemical bonds will be either adding, removing, or kind of a little bit adding, removing. So electrons are so versatile that there's a lot you can do here, and that's what will form our chemical bonds, and most of what we will spend the rest of the class looking at. As I give you some more stuff on stuff like atomic number, I'll do that very soon. But for now, there is some ideas on what is going on inside atoms, and I hope you enjoyed. See you soon. Bye-bye.